The question we have to address in this problem is the following. We are defining a new type of correspondence which is called circular if it fulfills this property. If A is related to B and B is related to C, then C is related to A. This is pretty much similar to the transitivity property, because the transitivity would say if A is related to B and B is related to C, A is related to C. However, here we have the reverse relation. That's why it's called circular. A related to B, B related to C, then C is related to A. So it's like you have A, B, and C here, okay? If A is related to B and B is related to C, then C is related to A. This is what a circular correspondence means. What we need to prove about this type of correspondences is that if they have this property and reflexivity, that is equivalent to saying that R is an equivalence relation. So R is an equivalence relation if and only if it is circular, so it's got this property, and it's reflexive, right? So we have to prove this in the two directions. So first we have to assume that R is equivalence, so an equivalence relation, and then prove that R is circular plus reflexive. And second, this is one. And then second, we need to prove that if R is circular plus reflexive, then it's an equivalence relation. Okay, let's go for first. Well, R is an equivalence relation, means that R is reflexive, symmetric, and transitive. Okay, well, it is reflexive, so we already have this one. Now, if it is transitive, then it means that if A is related to B and B is related to C, then A is related to C. But since it is also symmetric, that means that C is related to A. So if you have this, then C is related to A, and the relation is circular. So that proves the first statement. Okay, the second. Now we're going to assume that R is reflexive, and it is circular. Okay. All right. Well, reflexivity is already there. Okay. Right, because reflexivity is the first property we need to check for to prove that this is an equivalence relation. Now, let's see symmetry. Suppose that A is related to B, right? Then we also know that B must be related to B because it is already reflexive, and because it is circular, if A is related to B and B is related to B, B is related to A. So if A is related to B, B is related to A, which means it's reflexive. Okay, and now transitivity is straightforward, because if A is related to B and B is related to C, because it's circular, we know that C is related to A. But now we know it's also reflexive, so it means that A is related to C, and that is transitivity. So it's also transitive. And that's it.